Okay, so 1/2 of the third side. So that's the mid-segment of a triangle theorem. So the mid-segment of a triangle is equal to 1/2 of its third side. So let's try to prove this theorem. So given that we have here triangle MNB, okay, triangle MNB with A as its midpoint. Okay, we have here point A as the midpoint of MN and I as the midpoint of MB. And we want to prove that AI first. We have two things to prove. First is that AI is parallel to NB, and the second one is that AI, the mid segment is equal to 1/2. Okay, 1/2 of the third side. So the third side is the side where the mid segment does not cross. It doesn't cross that side, so it's NB. Okay, 1/2 NB. So this is the one that we have to prove. So how do we do that? So we have here the proofs. So for number 1, we have your triangle MNB, and A is the midpoint of MN and I is the midpoint of MB. So those are given. For number 2, we have AI is the mid segment. So a mid segment joins midpoints of two sides of a triangle. So that's the definition of a mid segment. And number 3, through point B, draw a line parallel to MN. Okay, so through point B, draw a line parallel to MN to this line, and then extend AI to intersect point L. So we are going to extend that. We're going to extend this line to point L. So through a point not on a line, only one line can be drawn parallel to any given line. So that can be the parallel postulate. Okay, so for number 4, we have here NA. Okay, NA is congruent to AM, of course, and MI is congruent to IB. And the reason for that is the definition of a midpoint, or the midpoint of a segment divides the segment into two congruent segments. Okay, so let's continue. Number 5, so we have here angle NMB. Okay, NMB is congruent to angle MBL. Okay, so those are parallel lines. Okay, so if we have your two parallel lines and we have your transversal, so therefore their alternate interior angles are congruent. Okay, and then we have MIA. Okay, so MIA is congruent to BIL because of the vertical angles are congruent theorem, because vertical angles are congruent. Okay, so again, guys, we want the proof to lead to this one. AI is going to equal to be 1/2 of NB, and it's necessary for us to extend this point to a line so that we can show that we have here a parallelogram of some sorts that will give us this proof later on. And then after that, we can say that triangle MIA. Okay, so this triangle is congruent to this triangle BIL through the A. Okay, so the angle S. Okay, the two sides. Okay, and A. Okay, AS. Okay, AS. Okay, so for the ASA, so we have here angle A. Okay, AMI, and also we have here angle IBL. Okay, so we have those two angles that are congruent to each other, and by using ASA, we can say that those two triangles are congruent. Okay, and therefore we can also say that their sides, that the corresponding sides of those two triangles are congruent. So we can say here that AM is congruent to BL, and AI is congruent to IL. So they're congruent because of DCPCTC, or the corresponding parts of congruent triangles are congruent. And also we can say that NA, okay, NA is congruent to BL. So that's substitution property of equality, because we said here that NA is congruent to AM and AM is congruent to BL. Therefore, NA is congruent to BL. Actually, this should be transitive. Okay, it could be transitive. Okay, transitive property of equality. Okay, and therefore we can say that we have here, okay, we have here a new figure here at the bottom. We can see that we have here parallelogram NALB. Okay, so we have here parallelogram NALB. Okay, so a quadrilateral with one pair of parallel congruent sides is a parallelogram because of our Okay, because we can see here that it's a quadrilateral with one pair of parallel and congruent sides, which are NA and LB. Okay, so we've already proved that, or BL. NA is congruent to BL. And also we have here AI is parallel to NB. The reason for that is a parallelogram is a quadrilateral with two pairs of opposite parallel sides. And AL, okay, AL is congruent to NB because the opposite sides of a parallelogram are congruent because we have there two opposite sides that are congruent. And therefore, we can say that AI, okay, line segment AI, okay, so this segment right here, okay, let's erase that, okay, line segment AI, okay, is equal to IL. Oh wait, no, I'm sorry. Line segment AL is congruent to NB. Okay, so opposite sides of a paragraph congruent, and AI is congruent to IL. Okay, because congruent figures have equal measurement. Okay, and also AL. Okay, AL is equal to NB. Okay, and then we have here AI plus IL is equal to AL. Of course, so that's the so that's the segment. Okay, so this is a segment addition postulate. So we're adding two segments here. Segment addition postulate. And after that, since we said that AI is congruent to IL, therefore we can write here 2AI, or AI plus AI is equal to NB. Okay, so since AL is equal to NB, we can write that here using the substitution property of equality. And 2AI is equal to NB. And if we divide both sides by 2, therefore we get that AI, our mid-segment, is equal to 1/2 of the third side, which is NB. And therefore we have proven our theorem here, our formula here. AI is equal to 1/2 the third side, or NB. Okay, so now that we have proven the mid-segment triangle theorem, so let's try to use the theorem. Okay, so we have here given triangle GAP with midpoints Q and D for the line segments GA. For GA, we have here a midpoint of Q, and for AP, we have here a midpoint of D. Okay, so for this problem, we want to know the value of GP, or we want to find the measurement of GP. Okay, so we have here QD is equal to 9x, and also we have here QD is equal to 1/2 of GP. Okay, so therefore we can write here, to find the measurement of GP, we can write 9x is equal to 1/2 of GP, or simply this is going to be 9x is equal to GP over 2. And if we divide if we multiply both sides, or both sides of the equation, to 2, okay, so this one cancels out, and therefore GP is equal to 18x. Okay, so therefore that's the value of GP.